In this video, we are going to look at load balancing on the Cambium network's PMP 450M as it relates to MU-MIMO. To understand load balancing, we need to explore the role of spatial frequencies, interpret the distribution of spatial frequencies on an access point, and look at when a subscriber module can be moved from one AP to an adjacent AP to improve performance. Start by looking at load balancing. Sector optimization, which includes the concept of load balancing, is an important part of any network. In Cambium Network's PMP 450M, load balancing plays an important role because of the nature of MU-MIMO. With traditional radio frequency, moving one trouble subscriber module from one sector to another may just mean that you are moving the problem to a sector where there is more ability to support it. With MU-MIMO, it is actually possible to move a troubled subscriber module from one sector to another and improve the performance of both sectors. PMP 450M is capable of communicating with up to 7 SMs at once. With MU-MIMO, whether communicating to a single SM or to 7 SMs all at once, the load on the frame can be essentially the same. In general, the two things that are needed to be able to group subscriber modules is traffic and spatial separation. Traffic is something that we have little to no control over and can be unpredictable. Spatial separation in itself is difficult to change, but by moving SMs between adjacent sectors, we can change the distribution of SMs and improve the chances that they will be groupable when they need to pass traffic. The distributions of subscriber modules can be best seen in the AP under Statistics and then Frame Utilization. The 1024 possible spatial frequencies are broken into 32 buckets of 32 spatial frequencies each. Each subscriber module is shown in its corresponding bucket. Consider these two APs with 65 subscriber modules each. You will notice the second AP has fewer grouping opportunities. Even though classified as a 90-degree sector, the PMP 450M access point is capable of supporting customers out to 120 degrees, while still supporting MU-MIMO. In this example, there is an additional 4 dB drop in RSL going from the 90-degree edge of the sector to the 120-degree mark. For subscriber modules that are close to the tower, this may be acceptable. This gives us the ability to load balance between sectors to help improve spatial distribution. In this example, notice the pattern of the spatial frequency in relation to the azimuth. At the peak of the sector, the spatial frequency is 0 and increments as the azimuth increases. It rolls over to 0 between the 140 degree and 145 degree SMs. The spatial frequency continues to count up until it extends past the usage range of the sector. Starting at the peak, if we decrease in azimuth, the spatial frequency also decreases, immediately rolling over to 1023. It continues to count down until it reaches 0, between the 35 degree SM and the 40 degree SM, where it rolls over again and continues to the edge of the sector. It should be noted that there is not a one-to-one correlation between azimuth and spatial frequency. Every spatial frequency is represented twice, with some spatial frequencies being represented 3 times. There are 3 steps to load balancing SMs. Step 1. Identify SMs that could potentially be moved to an adjacent sector. Step 2. Run an AP evaluation on each SM to determine the viability of the move. Step 3. Move SMs that are viable and would improve spatial distribution. So how do you identify eligible SMs? SMs on the edge of the sector will fall into the spatial frequency ranges of either 0-383 or 64-1023. However, just because an SM falls into this range does not mean that it is located on the edge of the sector. Either the AP evaluation tool or mapping software will be needed to determine this. If you look at the distribution of spatial frequencies for this AP, you will notice that it is not a very clean distribution. Most of the SMs seem to fall in the first few hundred spatial frequencies. This is undesirable and can hamper the overall benefits of MU-MIMO. For each candidate SM, log into the GUI and browse to Tools and then select AP Evaluation. Make sure that the adjacent sector frequencies are in the scan list of the SM and click Rescan APs. If the adjacent sector is a viable alternative, then it will show up in the list with the RSL similar to the currently connected AP. If the difference in RSL levels makes it acceptable to move the SM, reconfigure the color code of the SM, leaving the original AP color code as a secondary. Once the SM has connected to its new AP, wait 2 minutes to allow it to acquire its spatial frequency, and run a multiple VC link capacity test to make sure it's grouping well. If it does not obtain a valid spatial frequency, or it does not group well during the multiple VC link capacity test, then it might make sense to move it back to the original AP.